A very good morning to all of you. I am Dr. Neetu Gahlot. I am working as an assistant professor in St. Andrews Institute of Technology and Management, Gurgaon. I am the chemistry faculty of Applied Science Department. So today, the topics of my lectures are the demineralization or ion exchange process of water, and the another topic of my lecture is the introduction of corrosion. So today I start my topic, that is the ion exchange process. First of all, we will discuss about the ion exchange process. As we know, we convert the hard water into the soft water. So it is the softening process of water. And according to this softening process, now we use the ion exchange process. In this softening process of water, we have already discussed the lime soda method and the zeolite method in our previous lecture. So now we start our ion exchange process. In this process, there is the completely removal of the ions. Ions means these may be cation or the anion, which are already present in water. They can remove by the ion exchange process. So in this process, we use a ion exchange resin, which is a cross-linked and long-chain organic polymer. Generally, polystyrene divinyl benzene is used as an ion exchange resin. The functional group of resin may be acidic or the basic. So on the functional group of ion exchange resin are of two types. Here, the first ion exchange resin is a cation exchange resin, and the anion second one is the anion exchange resin. So first of all, we have required the ion exchange resin, or it may be cation exchange resin, or maybe the second is a anion exchange resin. So first of all, we know that the what is the cation exchange resin. According to this, cation exchange resin, these contain acidic groups, just like the carboxylic group or the sulfonic group. So these are usually the copolymer of styrene and divinyl benzene, which on the carboxylation or the sulfonation, they become as a cation exchange resin. That is, such type of the resin is exchange their H positive ion with the cation in the hard water. For example, a cation exchange may be represented as this structure. So this is the cation exchange resin, and we can represent this cation exchange resin as a RH, where R is the resin network of simplicity, and the another is the anion exchange resin. The anion exchange resin, in this anion exchange resin, there is the functional group is basic. So these are usually the copolymer of the styrene and divinyl benzene containing a amine group. For example, an anion exchange resin may be represented as the picture. This is the structure of the anion exchange resin. In this, the Me means that is a methyl group. So it anion exchange resin, we can represent it as anion exchange resin is a R-OH. As the uh, cation exchange resin, here the cation exchange resin is represented as the RH, but the anion exchange resin is represented as the R-OH. For their simplicity, so where the R dash is represented as the resin network also. Now, what is the working process of the anion exchange? Working process of the ion exchange process. Here, here is a apparatus. With the help of apparatus, I uh, explain our working process. In the ion exchange apparatus, there are the three columns. These are the three columns here. In first column, and these columns are interconnected with the help of pipe. So in the first column, here is a cation exchange bed and the gravels. In the second column, there is a anion exchange bed and the gravel. And the third column is called degasifier. So the work of the degasifier is, if the any gas like carbon dioxide, suppose carbon dioxide is present in the water, so this degasifier can remove our gases from the water, so that we get a demineralized water, or we can say it is a deionized, or the without the ions. These are the uh, water. So in the working process, first of all, we enter the impure water. Impure water means that is the water which has the hardness. So these hard water, goes to the first column. This column is cation. In this column there is a cation exchanger. Cation exchanger means here it is the RH, as we have already discussed, that is the RH, represented as RH. This RH, so here when the impure water is entered into this chamber, this column, so all the cationic part of hard water, means calcium or magnesium, they can be exchanged by the acidic part. They can be exchanged by the H part from the cation exchanger. And now the water comes into the second column. In this column there is a anion exchanger, so that all the anionic part of hard water is replaced by the OH negative. In this anion exchanger there is a R-OH, so OH is replaced the anionic part of the hard water. And after that, whenever water comes to the water, which becomes cationic or anion, is not present in this water. So now this water goes to the third column. And in the third column, there is, if the water has the any gas, so these gases can be removed in this degasifier. And after the end of the working process, so we collect our demineralized water. Now, when the working process is continuous, so after some time, the cation exchanger or anion exchanger will become the exhaust condition. So now how can we replace them, or how can we wash them? So for washing process, or that we can say that is the regeneration process, we use the acid for the regeneration of cation exchanger, and we use any alkali for the regeneration of anion exchanger. Here is the working method, this one. The cation exchanger and anion exchanger both are interconnected with the pipe, as in our picture. The hard water is passed through first cation exchange resin. So in this column, all the calcium and magnesium present in water, they get exchanged by the H positive from the cation exchanger. So this is the reaction, that RH reaction with calcium and gives the RCA, and when the magnesium is there, so it gives the R2Mg. So then the treated hard water. Now the treated hard water, uh, which has already removed the cationic part. So water is passed through anion exchanger resin column, where the anions, like the sulfate, or it can be chloride also. So these present in hard water are replaced by the OH ions from the resin. So here the R-OH is present in the second column. Then it's called the anion exchanger. So R-OH is reacted with chloride and gives the RCl, R-Cl, and the R-OH is reacted with the sulfate and it gives the R-SO4 negative. So now the release the H positive from cation exchanger treatment and the OH negative from the anion exchanger treatment. So we get combined to produce the hard water. Produce the water. That means H positive plus OH negative, and it gives the H2O. It is called the deionized water. That is the free from cation and anion. Here, this is the our apparatus. And what will do when the cation and the anion exchanger will be exhaust. So for the regeneration of resin, first of all, for cation exchanger, we use acid, and reaction is there, R2Ca plus 2H positive. This H comes from the acid. Suppose the acid may be HCl, dilute HCl, or H2SO4. So the acidic part comes from this side. So this RCA plus H positive, it gives the RH, which is this one is our cation exchanger. And R2, suppose magnesium is there, so then it converts the RH again, RH. So that is again जो है हमारा वो है हमारा cation exchanger. And for the regeneration of the anion exchanger, suppose it is the R-SO4 and the OH negative. OH comes from the alkali, which is used for the regeneration of anion exchanger. So this may be NaOH. So OH comes from the NaOH, and after the reaction, it converts the R-OH. So here we again get our anion exchanger, and the second, if the Cl is present here, so R-Cl is react with the OH negative, and it gives the R-OH plus Cl negative. So this is the regeneration process of the resins. Now, every method has its advantage or some disadvantages also. So first of all, we have discussed its advantage. By this process, the water has very low hardness. It may be approximately less than 2 ppm. Second, the highly acidic and the highly alkaline water also can be softened by this method. By the using of this water, the corrosion are reduced. So these are the advantages, and now there are some disadvantages also here. So first, the ion exchange process apparatus, these equipments are very costly, and the regeneration of the resins, it is these are the regeneration of the resins are also very costly, and the turbid water decrease the efficiency of resin. So these are the advantages of the some disadvantages of this process. And this is the third part of our third method of our softening process of water. In the previous lecture, we have already discussed the lime soda method and the zeolite method, and then the uh, this one is the ion exchange method. So according to these three method, we have the residual hardness from the lime soda method. So it if we use the cold soda lime method, so that means there is a hardness will be 50 to 60 ppm, and the for hot soda lime method, the residual hardness is the 15 to 30 ppm, and from the zeolite method, the residual hardness becomes 10 ppm, and for using of the ion exchange process, the residual hardness is less than 2 ppm. So this is the best method for the softening process. And now here is a very short or small very short method. This is called the mixed bed deionizer. Mixed bed DRS, as we know that in the ion exchange process, there are the three chambers, or we can use the two columns for the exchange of a resin. But in the mixed bed deionizer, there is only a one column. And in this column, there is a cation exchanger or anion exchanger are also presented here together. But when we enter the raw water in this column, so this is this part is a mixed bed deionizer bed, and it means that here cation exchange and anion exchanger are present in the same place. So after so that hard water when comes in the contact with the both exchanger several times, so it is highly efficient process than separate column of ion exchange process. The purified water contains very less, about the 1 ppm hardness. It is more convenient and the widely used. तो बहुत छोटा सा apparatus है, हम इसे कहीं भी सेट कर सकते हैं. So and the residual hardness is only 1 ppm. एंड आफ्टर द एक्सोशन कंडीशन इज ऑल्सो हेयर, पूरा फिल हो जाएगा तब हम उसको हाउ कैन बी regenerate. So for the regeneration of the anion exchanger, we use the NaOH solution, dilute NaOH solution, and for the regeneration of cation exchanger, we can use the dilute H2SO4. So now, like these are the ion exchange should possesses following properties. These properties are the they should not produce any color or bad smell in treated water. And second, they should be non-toxic, cheap and easily available. Third, they should be highly stable and inert for chemical attack. And the fourth is their regeneration and washing should be cheap and easy. So now uh, we complete our softening process of water. And the very small definition, and it is an important definition, the desalination. Desalination means the removal of the all salts from the water is called desalination. So question arises that classification of water according to the salinity. So then the desalination is the process of removing dissolved solids like NaCl, etc. from water. On the basis of dissolved amount of solids, water is classified as. So as we say that as we know that the according to the classification of the water from its based on the salinity, it can be divided into the three part. That one is the first part is the fresh water, second is the brackish water, and the third is the sea water. So, amount of the dissolved solids in the fresh water is the less than 1000 ppm, and for the brackish water, the dissolved solids amount of the dissolved solid is the 1000 ppm to 3500 ppm. And for the seawater, the salinity is greater than 3500 ppm. So this is the classification which is based on the salinity of water. So now I completed my water chemistry part, and my second topic of this lecture is the introduction of corrosion. First of all, we know about corrosion. एवरीबडी नो द corrosion. हम लोग सिंपली कह देते हैं कि भाई जंग लग गया, हमारा कूलर खराब हो गया, पॉलिश नहीं की, तो ये है आपका जंग लगना, जिसको हम नॉर्मली समझते हैं कि जंग कहाँ लगा, कि आयरन के ऊपर लगा, लोहे के ऊपर लगा। तो कैसे लगता है? तो इंट्रोडक्शन ऑफ द corrosion, इट इज एक दिन में कभी नहीं लगता, इट इज अ स्लो प्रोसेस. दैट इज द प्रोसेस ऑफ स्लो destruction or detonation of metal due to chemical or electrochemical attack of the environment at their surface, resulting into the formation of compound such as oxides, it may be carbonate, etc. Or this is called the corrosion. तो धीरे धीरे मेटल का डिस्ट्रॉय होना by the chemical or the electrochemical attack on the surface of metal, then the formation of the oxide or maybe carbonate, this process is called the corrosion. मतलब कि हमारा मेटल को धीरे धीरे केमिकल और इलेक्ट्रोकेमिकल अटैक की वजह से जो खराब होना है, इट इज कॉल्ड द corrosion. और हम लोग नॉर्मली मानते हैं कि corrosion कहाँ होता है, कि आयरन के ऊपर होता है, बट ऐसा नहीं है, और भी मेटल्स हैं जिनके ऊपर corrosion होता है. So the most common example of corrosion is the rusting of iron. रस्टिंग ऑफ आयरन मीन्स जो जंग लगना है, जिसको हम जंग लगना बोलते हैं, दैट इज द रस्टिंग ऑफ आयरन. रस्ट क्या चीज है? व्हाट इज रस्ट? रस्ट क्या है? रस्ट इज अ हाइड्रेटेड फेरिक ऑक्साइड. द मॉलिक्यूलर फॉर्मूला ऑफ द रस्ट इज Fe2O3 into X molecule of H2. So this is the rust. If we remember, the molecular formula of rust is important. That is the Fe2O3 into X molecule of water. This is the rust. And do you know the another example of the corrosion? Yes, the tarnishing of silver. जो चांदी हमारी खराब हो जाती है, काली काली पड़ जाती है, this is the another form of the corrosion. So the tarnishing of silver is another type of corrosion, and the development of green coating of basic carbonate on copper and bronze etc. जो उनके ऊपर हरी कोटिंग आ जाएगी कॉपर के ऊपर, वो भी हमारा corrosion ही होता है. बट corrosion क्या करेगा? corrosion होगा तो हमारी जो मशीनें हैं वो खराब होंगी, है ना, और या फिर उनकी जो एफिशिएंसी है, काम करने की एफिशिएंसी है, वो लगातार कम होती जाएगी. सो corrosion क्या करता है कि corrosion destroy the metallic equipment. Corrosion destroy metallic equipment, machines and instruments, and it reduce the efficiency of our machines. So in this chapter, we would learn the type of corrosion, their mechanism, the factors affecting corrosion, and measures which are usually adopted for their prevention. So these are the important subtopics of this chapter. Uh, it These are the mechanism of corrosion, types of corrosion, factors affecting corrosion, and how can we prevent metal from the corrosion. So now the types of corrosion. Firstly, corrosion, normally we read that the corrosion may be two types. That is, the one is a dry corrosion and the another is a wet corrosion. But so many other type of corrosion are present. And the dry corrosion is also called the chemical corrosion. Or dry corrosion, as the name suggested, that the corrosion is completed in the absence of moisture. It's called dry corrosion. So another name of dry corrosion is the chemical corrosion. The wet corrosion is also called the electrochemical corrosion. Dry corrosion is called chemical corrosion, and the wet corrosion is called the electrochemical corrosion. And so many other type of corrosion like the atmospheric corrosion and other forms of the corrosion are present. So that the dry corrosion, the causes of dry corrosion, the causes of dry corrosion by the oxygen, by the gases or by the liquid matter. And the types of wet corrosion have the different types. This is a galvanic corrosion, or galvanic corrosion is also called the bimetallic corrosion. So first is the galvanic corrosion, or we can say that it is the bimetallic corrosion. Second is the pitting corrosion, and third is the differential erosion corrosion. Next is the waterline corrosion and stress corrosion, and other types of corrosion are also present. These are called just like the soil corrosion and the microbiological corrosion also. So these are the types of corrosion. But in brief, we discuss the dry corrosion or the wet corrosion. And the wet corrosion, types of wet corrosion is also we will also discuss. सो नाउ कि कोरोजन होता कैसे है, अगर छोटा सा हम प्रोसेस पे डिस्कस करेंगे कि मेटल से कोरोजन कैसे होता है। कि वी नो दैट प्योर मेटल डज नॉट कोरोड, कि जो भी प्योर मेटल है तो वो कभी भी कोरोजन उस पर नहीं होता है। मेटल के पास मेटल को खराब कब होगी, व्हेन अ मेटल कम्स इन द कांटेक्ट ऑफ एटमॉस्फेयर, जब वो एटमॉस्फेयर के कांटेक्ट में आएगी तब हमारी मेटल खराब होगी। So when the metal comes in the contact with air or oxygen, so it forms a metal oxide layer. Okay, so when a metal comes in the contact with the air, that means then it forms a metal oxide layer. The continuation of the oxidation, कि अब वो metal oxide की layer बन गई है, अब हमारा corrosion होगा या नहीं होगा, वो डिपेंड करता है, it depends on the layer of metal oxide. That is, the continuation of oxidation process is depend upon two factors. First factor, the nature of the oxide film, and the second is the rate of diffusion of the metal ion and the oxide ion through the layer form. हमारा डिपेंड करेगा कि लेयर कैसी है, वो किस पे फर्दर कोरोजन हो रहा है या नहीं होना है, वो हमें बताएगा, ये मेटल ऑक्साइड की लेयर बताती है। So the continuation of the oxidation process depends upon the two factors. The first factor is the nature of oxide film form, and the second factor is the rate of the diffusion of metal ion and the oxide ion through the layer. हमारी जो ऑक्साइड लेयर की लेयर ऑक्साइड मेटल ऑक्साइड की लेयर जो फॉर्म हुई है, वो डिसाइड करेगी कि भाई अब हमारा फर्दर कोरोजन टेक्स प्लेस और नॉट. बट when the oxide film is stable, it may be depend upon the nature of metal. Okay, so first of all, when oxide film is stable, अब अगर हम कह रहे हैं कि हमारी लेयर स्टेबल होती है, तो अगर सपोज वी टेक द एग्जांपल ऑफ द एल्यूमिनियम, कॉपर और मेटल, so aluminum, copper and lead, if these metal are present, so that they form the stable layer with the oxygen. ठीक है, तो then when the oxide film is stable, तो it act as a protective coating. तो protective coating होगी, that means the further corrosion does not take place. Okay, and second, the unstable and the decomposed back of metal and oxidation corrosion can't continue. So the metal may be silver, gold, platinum, etc. And the third type of layer is called the volatile layer. Volatile layer means कि layer बनी और वो वेपर हो खत्म हो गई. तो मेटल सरफेस अवेलेबल फॉर द कंटिन्यूअस अटैक. इट मीन्स क्या, कि बन रही है और जा रही है, तो इसका मतलब कि वहाँ पे बार बार उसको ऑक्सीजन को अंदर आने का टाइम मिल रहा है. तो व्हेन द मेटल सरफेस इज अवेलेबल फॉर द कंटिन्यूअस अटैक इन द volatile film is formed, and the metal this which form this type of volatile layer is called the molybdenum. The metal is the molybdenum which form the volatile layer. So this is the reaction MO plus 3O2, it gives the 2MOO3, that is called the metal oxide or molybdenum oxide. That form the volatile layer. Now the oxide film is oxide film may be porous or non-porous. Okay, so oxide film is porous in nature. So this is based on the Pilling Badworth rule. Here, यहाँ पे एक रूल काम करता है जिसको हम बोलते हैं Pilling Badworth. So according to the Pilling Badworth rule, कि if the metal oxide film is non-porous, Metal oxide film is non-porous, so that means it is a protective. So protective means कि further corrosion does not takes place. वे लेयर प्रोटेक्ट कर रही है तो इसका मतलब वहां पे corrosion नहीं होगा. Okay, and if the metal oxide film is porous, तो that means pores है, उसको अंदर जाने के लिए जगह मिल रही है, तो it means the formation of the non-protective layer, and non-protective layer means the further corrosion takes place. कि लगातार वहाँ corrosion चलता रहेगा. So this is the peeling bad worth rule, and it is a very important rule for the corrosion. तो corrosion हमारा किस पे depend किया? Nature of the metal and the layer of the oxide film. ये दो बहुत important चीजें हैं जिनके ऊपर हमारा corrosion depend कर रहा है. And one more thing कि volatile film is formed when the metal is molybdenum. Okay, so now I repeat again, corrosion. In this lecture, we have discussed that the definition of corrosion. First of all, we have discussed about the definition of corrosion. We had discussed the rust. Now we know that the molecular formula of rust. The another examples of the another example of the corrosion, and then the topics which are related to this chapter is the definition, types, mechanism, factors affecting, and how can we prevent. And the types of corrosion, dry corrosion and wet corrosion are the main type of the corrosion, and there are so many other type of corrosion present. And the dry corrosion by the oxygen, by the gas, by the liquid metal, and wet corrosion, these are the types of wet corrosion: galvanic or bimetallic, pitting, differential erosion, waterline, and stress corrosion. So here these are the types of corrosion. And now at the last of our video, we discussed the formation of metal oxide layer. So when the metal oxide layer is formed, so it it depends, the corrosion depends upon this layer. So this layer may be stable, depends upon the nature of metal, unstable, again depends upon the nature of metal, volatile for the molybdenum, and the oxide film may be porous or the non-porous in nature. So that the peeling Badworth rule is here. If the protective layer is formed, so further corrosion does not take place, and if the non-protective layer is formed, so the corrosion takes place. Okay, so that now the two questions here. First question from my this lecture is, okay, what do you mean by the softening process of water, and explain the ion exchange process in detail. I repeat again, what is the softening process of water, and explain the ion exchange process in detail. And don't forget the structure of cation exchanger or anion exchanger. It is required. And the second question is, explain the peeling Badworth rule. Okay, so I repeat my questions again. First question is what is the softening process of water, and explain the ion exchange process in detail. And second question is, explain the peeling Badworth rule. So now I stop my lecture, and if you have any query, so you can discuss with me. Thank you.